Chapter Review Study Guide. This is going to cover problems related to relations and functions. So question 1, write the domain and range of each function. Just a reminder that the domain is always your independent variable, or in this case, it can be our x coordinates, and our y is our range, which would be our dependent variable. So here we want to put it in a set. So we have our domain first, and our domain would just be our x coordinates. This would be -3, -2, 0, 1, and 4. And then the range would be our dependent variable, which is our y coordinate. And we would have -1, 2, 5, 9, and 10. Now, if any of these would repeat, so if there's any x coordinates that repeat, you only need to put it down once. And the same is true for the range. The next one, we have -2, 0, 2, or -2, -1, 0, 0, 2, 1, 4, 3, and 6, 5. So I'll define the domain again, which would be our x coordinates. And here the domain would be -2, 0, 2, 4, and 6. And then the range would be -1, 0, 1, 3, and 5. Question 2. Here we want to write the domain and range for each relation. So I got two relations here. One's a mapping diagram and the other one's going to be a graph. And then we want to determine if it's a function. So first off, the domain. Again, the domain is just our independent variable. And so this would be this mapping circle. So I would have our A, our N, our M, and then our H. And then the range would be this other mapping circle. So this would be C, H, and N. Now, to determine if this is a function or not, I look at the domain. And for the domain, you can only have one domain and one range. So here, I only have one line leaving the domain to a range. So as long as, for a mapping diagram, as long as one line leaves the domain, it would be a function. So yes, this is a function. Letter B, here we want to do the domain here. The domain here is talking about our x coordinates, and this keeps going out in both directions. So the domain, so for a parabola shape like this, the domain is going to be x such that x is all real numbers. And then the range is talking about where it crosses the y-axis. So this is the lowest the y-axis it goes. It crosses the the x-axis, or the y-axis, and it keeps going above that one. So we would say the range would be y such that y is greater than or equal to 0. It never goes below the x-axis, where the x-axis crosses the y-axis at 0. So everything equal to 0 and above 0. Now the question is, would this be a function? And if you were given a graph, you would just do the vertical line test. So if I do a vertical line here, it only crosses in one spot here. So because it only crosses in one spot, this would be a function. So yes, this is a function. Question 3. If f of x equaling x squared minus 3x plus 4 and g of x equaling the absolute value of -x minus 12, what is -2 times brackets f of -4 plus g of 2? So here we're going to substitute the value that they give us for x for each individual function and then simplify it. So right now I got -2 and then brackets, and then I got to put -4 in for f of x. So this would be negative 4 squared minus 3 times negative 4 plus 4. And then to that one, I'm going to be adding, putting 2 in for g of x. So this would be the absolute value of negative, and then parentheses 2 minus 12, end bracket. So let's simplify this one. So negative 4 squared is 16. Negative 3 times negative 4 is a positive 12. And then I got plus 4. And then here I have the inside the absolute value, I got negative 2 minus 12, which is negative 14. And then the absolute value of a negative 14 is a positive 14. And then this is all in brackets. And now I'm going to simplify what's in the bracket. So 12 plus 16 is 28. 28 plus 4 is 32. And 32 plus 14 would give us 46. So we got negative 2 times 46. And then if I multiply those together, this will give us a negative 92. Question 4. Rule y equals negative 3x cubed represents relation n. What is b if negative 3 comma b belongs to n? So for this one, they're giving me a coordinate that works on it. So if I substitute these in, so that again, this is my x and this is my y. So I'm trying to find my y. So I'm going to put a b in for y. And I got negative 3 times my x is negative 3. And then I have to cube that. So negative 3 cubed is a negative 27. And negative 27 times negative 3 would give us our b. And negative 3 times negative 27 would give us a positive 81. So b would be 81. Question 5. A limousine ride costs $35 plus $5.50 for every mile m you ride. Which function rule describes the cost of the limousine ride? So I'm going to do f of m equals, now it costs $5.50 per mile, so 5.50 m plus the $35 that you have to pay no matter what. Question 6, Cheryl gets paid $11.50 for every hour she works at a restaurant. She also collects $50 in tips per week. What is the function rule that describes Cheryl's weekly salary? So here we need a variable, so we're going to use h for our variable. So I'm going to do f of h equals, so $11.50 per hour plus she gets $50 per week. So that would be our function for there. Number 7, find the next 3 terms in this arithmetic sequence. So for arithmetic sequence, we're going to be using the formula a subscript n equals a subscript 1 plus n minus 1 times the common difference. So to find the common difference, I look to see what there's a pattern. To go from negative 6 to negative 2, I'm adding 4. And negative 2 plus 4 gives you 2, and 2 plus 4 gives you 6. So the common difference is 4. And then I need to find the next 3 terms. And the first term, so I'm not going to use that formula. I'm just going to use the common difference. So the next one, 6 plus 4, would give us 10. 10 plus 4 gives us 14. And 14 plus 4 gives us 18. So these would be the next 3 terms of our sequence. Moving on to our next problems. So in question 8, find the next 2 terms in this sequence. So to determine if this is an arithmetic sequence, if I would take 7 halves, but I need to put it into fourths, so I can do the subtraction. So if I multiply 7 halves by 2 halves, that gives me 14 halves. So if I have 14 halves, or 14/4, I mean, minus 11/4, that's going to give us 3/4. So that means we're adding 3/4 each time. So now if I take my last number I have, which is 5, but I'm going to put that into fourths, which was 20/4, because 20 divided by 4 is 5. And if I add 3/4 to that, that gives us 23/4. And then if I add 3/4 to that, that's 26/4. And 26/4, I can reduce that, so you should always reduce it, would give us 13/2. And then if I take 26/4 and add 3/4 to it, that's 29/4. So these would be the next, and I only had to do the next two terms, so the next two terms would be 13/4 and 13/2. Question 9, write the function rule to find the nth term of this arithmetic sequence. So I'm going to be using the formula a subscript n equals a subscript 1 plus n minus 1 times the common difference. Now it looks like we are adding 3 each time, so that's our common difference. So I need to find the nth term when the first term is 1 plus n minus 1, and then this is going to be times 3. Now I don't want to leave my equation like this, so I'm just going to distribute the 3. So this is going to be a subscript n equaling 1 plus 3n minus 3. And then I can just simplify that, which my formula would be a subscript n equals 3n minus 2. And I can verify that that is correct, because if I want to find the second term, I would put a 2 in for n. 3 times 2 is 6. 6 minus 2 is 4. And the second term here is 4. Question 10, find the indicated term of the arithmetic sequence. So we have a subscript 10. So we want to find the 10th term of 11, 5, -1, -7. So we're going to use the same formula that we just used above, but I need to find the 10th term. So the 10th term, when the first term is 11 plus the 10th term minus 1 times the common difference. And the common difference here is I am subtracting 6 each time. So now I have 11 plus 9 times -6 is -54. That means a subscript 10 is going to give us a negative. So -54 plus 11 is going to give us a -43. Question 11, your job has a starting salary of $30,000. Your annual increases of $1,200. So every year you get $1,200 more. How much will you earn in the 5th year? So this is the same thing. We're going to try to find a subscript 5, which the first year you're getting paid $30,000, plus this will be 5 minus 1, and the common difference is $1,200. So I'm just going to put this on my calculator to make it go a little bit quicker. So we have 30,000, and this is going to be plus 4 times 1,200. That gives us $34,800. Question 12, what are the 3 terms of this geometric sequence? So with geometric sequences, you are multiplying by a common ratio every single time. And to find the common ratio, you take one value, so I'm going to take -3, and divide by the previous y value, which is 15. And this is going to give us a -1/5. So that means we're multiplying by a -1/5, or if you think about it, you're really dividing by -5. So the next 3 terms, if I take my calculator, we have -3, and we're dividing by -5. Or if you want to multiply by -1/5, it's the same thing, and you get 6/10. So 0.6. And then the next one, we're going to divide that by -5. If I divide that by -5, you get -0.12. And then if I divide by -5 again, you get 0.024. Question 13, write the recursive formula for the nth term of a geometric sequence. Now the recursive formula would be a subscript n equals the common ratio times a subscript n minus 1. So we need to find the common ratio first, and so that would be 10.24. Divide that by 16, or not 16, a -12.8. So on my calculator, we have 10.24. Divide that by a -12.8, and that gives us a -0.8. So that means we would have a subscript n equals a -0.8 times a subscript n minus 1. And this would be our recursive formula. Question 14, if the first term of a geometric sequence is 0.5 and the common ratio is 0.7, what is the ninth term? So we would have a subscript n equaling a subscript 1 times r raised to the n minus 1. So we're going to use that formula. So we're finding the ninth term, so a subscript 9 equals, the first term is 0.5 times the common ratio of 0.7 raised to the 9 minus 1 power. So on my calculator, we have 0.5 times 0.7 raised to the 9 minus 1 is the 8th power. And that gives us a really long decimal. Let's see if we can put this into a fraction. So let's round this to actually, no, we can't round it. Let's put, we'll have a subscript n equals grab our calculator again, 0.0288. $24005. Now, most times you're not going to have a long decimal like that, but in this case, we end up having that long decimal because of raising that to a bigger power. And our last question, a biologist studies bacteria from a pond containing 200 microorganisms and notices that the number of organisms doubles every day. If the microorganisms continue to increase at this rate, how many will there be in 7 days? So we're going to use the same formula we have. So a subscript n equaling, and I'm going to, instead of use subscript n, I'm going to use find the seventh term, so in 7 days. So the first term starts off with 200 microorganisms times the common ratio, it's doubling, so that's 2, raised to the n minus 1, so that's 7 minus 1. So on our calculator, we got 200 times 2 raised to the 6th power, and that's going to give us 12,800. And that would be microorganisms. So that is a review on functions and relations.